Okay, we have looked at the carbon footprints for countries in various ways. There is another way to think about it, which it's recasting the whole equation, but it allows a different way to think about reducing emissions in this context. So carbon intensity is defined as CO2 emission per unit of GDP of a country, let's say. Okay, we have been looking at per capita emissions, country emissions, and so on, and then we are trying to see what we looked at what UK's carbon emission is made up of, and so on. But then there is the energy intensity of the GDP. So how much energy is used per unit of GDP, and then a fuel mix can be looked at where you are looking at carbon intensity of the energy. So you look at energy intensity of the GDP and maybe carbon efficiency of the energy mix, so that it gives you a sense of how to reduce emissions per energy so that you can reduce energy intensity of the GDP. So you end up totally reducing the emission per unit of GDP. So let's look at a few calculations along these lines. Carbon dioxide emissions per unit of GDP, kg of CO2 per constant, 2010 US dollars. CO2 emissions per unit of GDP are expressed in kilograms of CO2 per US dollar constant, 2010 PPP GDP. Okay. Price purchase parity GDP, I think that's what it stands for. So here we are looking at carbon dioxide emissions per unit of GDP, kilogram of CO2 per constant 2010 US dollar, and you can see that this list looks quite different than what we saw before. So you can think of this as carbon efficiency. So Turkmenistan, Kazakhstan, Bosnia Herzegovina, Ukraine, Serbia, and Russian Federation, they show up here, and then Germany is down here, US should be somewhere, United States is here, Austria, and then Switzerland, Malta, Norway, Ireland, France, they all show up in the bottom here. So this is a different ranking compared to CO2 emissions by countries. But the main thing is that since 2000, more than 20 countries have reduced annual greenhouse gas emissions while growing their economies. So this is the key part of key aspect of looking at carbon efficiency and energy efficiency, or energy intensity and carbon intensity of GDPs. Why? Because everybody wants to grow their GDP, and the idea is to grow the GDP without increasing greenhouse gas emissions. So this is a good way to look at it. So here are the changes in CO2 over 2000 to 2014, and change in GDP over the same time period. So Austria, Belgium, Bulgaria, Czech Republic, Denmark, Finland, France, and so on down to United States here, and Uzbekistan, UK should be here as well, United Kingdom. So you can see that various levels of change in CO2 have occurred, and all are negative numbers here, because these are the countries that have grown their GDPs at various levels, while in the meantime decreasing the annual greenhouse gas emissions. Obviously there are lots of details, because we are just comparing 2000 versus 2014. It's not an absolute reduction, it's a relative reduction, right? For example, US discovered huge natural gas reserves, and it switched from fossil fuels, reduced its coal burning and oil burning, to switch to natural gas, which is much more carbon friendly. So you have relative reduction in CO2, but US exported coal in the meantime, so we are not accounting for embedded carbon, traded carbon, exported emissions, and so on and so forth. So one has to be careful about that. Look here at the US CO2 emissions and GDP from 1950 to 2025. Again, relative. Total energy related carbon dioxide emissions in million tons of CO2, it has gone up it had been going up, and then it has taken a turn down, and this was in 2014. So this is GDP that had grown over the same period, and the forecast made at the time was that the GDP would continue to grow. Here GDP in billions of chained $2009, so the dollar is pegged to 2009, and then CO2 intensity of the GDP was forecasted to go down, and it's expected to cross and become negative per GDP somewhere in 2023 or 2024 or so. Okay, decoupling UK GDP and CO2 emissions. This already happened. So GDP had been going up since 2009, some financial crisis and back up, and CO2 emissions with respect to 2000 have dropped since about 2008. So just before the financial crisis of 2008, and it has continued to drop. So you have to then go and look at what it is that UK is doing for this decoupling. So here you look at CO2 emissions per capita versus GDP per capita in 2018. This puts all the countries together. So the measures CO2 emissions from fossil fuels and cement production only. Land use change is not included. GDP per capita is measured in international dollar in 2011 prices to adjust for price differences between countries and adjust for inflation. So in general, higher GDP comes with higher annual emissions per capita. So now you see that Tanzania is down here with its low GDP per capita, but its carbon efficiency is very low as well. Okay, so you have to keep those things in mind. In other words, if you want to move Tanzania to a higher per capita GDP, you would want to do it by keeping the annual emissions low. Or you can see that rich countries have become rich by having a higher annual CO2 emissions per capita. Okay, so this is another metric of absolute decoupling. Change in CO2, change in CO2 in percentage, metric tons, change in real GDP, and change in industry share of GDP, which we already looked at, but this just lists those countries that we looked at in the bar chart. Okay, so it's important to think in different ways because it gives you a different way of planning for reducing emissions while not reducing GDP, unless you are really bought into this idea of prosperity without increasing emissions, which is not going to be easy. If it can be done, great. It goes into the idea of whether economies need to be grown or economies need to develop. So development is supposed to be without causing harm to the environment, whereas growth is something that results in environmental harm. In fact, only after the Second World War there was a retail salesperson, Victor Lebo, who wrote a little article saying that the only way to grow economies constantly was to make things that didn't last very long so that people would discard them or they would become obsolete in a few years and people would be forced to buy new one, whether it's TV, washing machine, cars. Computers were not common yet in that during that time, but bicycles and so on and so forth. And that philosophy has been used. If you look at the way people change not just phones but refrigerators, cars, clothes even, or anything else you can think of, then this idea of growing the economy comes necessarily with increasing conversion of natural resources into irreversibly into junk, because many of these things cannot be recycled fully back. So the idea of circular economy that we talked about was to have everything completely recycled and not wasted. So things are not pulled off the ground, converted to junk to be piled up somewhere. Okay, so another way to look at this is to look at the world's biocapacity here, which is estimated in some way, like a carrying capacity. How much population can the world sustainably support? And then the number of Earths we need to achieve our goals of economic development. And there is the axis of human development, which is an index that includes children's health, education, women's health, education per capita GDP, access to health, education, water, electricity, and there are many factors involved. And the main message here is that if you want to be sustainable, you want to have a high human development index and a low number of Earths, which means you want to remain on one Earth and not try to colonize Moon and Mars for managing the population and our consumption levels. This is from 2017. You can also look at this in terms of ecological footprint with another index. But the main story here is that typically rich countries here, which have high human development index, also have a high ecological footprint, or they are exploiting resources which eventually would require us to have many Earths to support our lifestyle. So very high human index would need more than 9 Earths. Here is the North America, EU28 must be somewhere here, South Africa somewhere here, and here are the African countries, Middle East and Central America, Central Asia and Asia Pacific, and so on and so forth. So this gives you an index that if you wanted to move the poorer countries of Africa into high human development index, sustainable development would require that we remain resource bound and try to stay within one Earth and not go up this scale of consumption where we are essentially going beyond the biocapacity of our planet. Okay, so this is not directly about carbon footprint that we have been talking about in this book, but I wanted to add this podcast to give you a sense of how to think beyond just carbon footprint, even though carbon footprint of course is a very critical metric to look at for everything we have been looking at, from bananas to countries. Okay.